Hello, this is Mrs. Grisafi. We're on 11.01 today, so we're starting a new unit. I know I skipped over 10. We're going to come back to that after 11. That's going to be probability, but I wanted to go on to sequences and series next, so that's what we're going to do. The first thing we're going to start off with is talking about sigma notation, and then we'll get into the sequence and series for an arithmetic type. So for sigma notation, this big E right here, Greek letter E, is a sigma, and we also call these a summation. So it's just a symbol that tells us what to do. So what it's going to tell us, and this is in this box over here, if you see, we're going to start with whatever number is on the bottom. So that's a 1. We're going to stop at whatever number is on the top, and we're going to substitute them in and go up by ones each time. So consecutive integers from 1 to whatever number it stops at. So 5, we're going to end at 5. And so this should be a 5 there too, from n to the number on top of the summation. Then we're going to add up all of those together, hence the term summation. So here we go. We're going to put 1 in for n first. So 4 times 1 plus 2. Since this is all in parentheses, we're going to do all of it every single time. Plus, the next one is going to be after 1 comes 2. So 4 times 2 plus 2. Then we have I to the 4 times, after 2 comes 3 plus 2. Then after 3 comes 4, so 4 times 4 plus 2. And then lastly, I to the 4 times 5 plus 2. So I went, this right here was my n value, and it just went up by ones from 1 and stopped at 5. I subbed it in for the ends, and now I'm going to evaluate. So I'm going to simplify first. So 4 times 1 is 4, plus 2, plus I to the 8, plus 2, plus I to the 12th, plus 2, plus I to the 16th, plus 2, plus I to the 20th, plus 2. So I just multiplied the exponents together. So now you can either type this in your calculator, or if you remember your I circle, remember your I, negative 1, 1, it goes counterclockwise. And if I wanted to do I to the 4th, I would go 1, 2, 3, 4. So count 1, 2, 3, 4. So I to the 4th would give me a 1. So it's any groups of 4 are going to equal 1. So if it's evenly divisible by 4, then it's the same thing as 1. You could also go to your calculator. Remember, the I button is bottom middle. So second I raised to the 4th, hit enter, it gives you 1. So I have 1 plus 2. Then I do I to the 8th. Again, it's divisible by 4, so it's just going to be 1. Or if you count here, 1, 2, 3, 4, 5, 6, 7, 8, again gives you the 1. Plus our 2. I to the 12th, again, is going to give you 1. I to the 16th is 1. I to the 20th is 1. And again, you could type each of those into your calculator, and it would give you 1 as well. All right, so now we're going to just add up our like terms. So everything is like terms together. So we add all this up together. So you've got 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. So our final answer would be 15. Now I want to talk about how you can actually do this right in your calculator as well. Obviously, I want you to be checking it in your calculator, showing me out all the work. So to check it in your calculator, you're going to hit Alpha Window, and then you're going to go to the summation. So here I'm going to hit Alpha Window, and then I'm going to hit Choice 2, which is your summation. And I'm going to type in X equals, and my bottom number was 1. So I'm using X instead of N. And the top number is 5. And then in here, I'm going to do second I raised to the 4X down plus 2. And that all stays in parentheses. Hit enter, and it gives me the same answer we got of 15. Okay, so alpha window number 2. Let's try another one. So this one, I got a couple other things going on here. We have a 1/2 out in the front. And then in this case, this is not in parentheses, that 8. So we're not going to add it each time. So I'm actually going to rewrite it a little bit differently. So I'm going to put the 8 here so we don't get confused. So 8 plus 1/2 summation from k equals -2 to 3 of -k. So the 8 and the 1/2 is only going to happen once. They're going to happen at the end. So I'm going to have 8 plus 1/2. And then in parentheses, I'm going to start at the bottom number, subbing -2 in for k. And I'm going to stop at 3. Okay, so this gets a little confusing just because of the negatives, but there's not a whole lot of calculation that you need to do. So if I sub in a -2 here, that's -k, so negative, and I'm subbing in a -2 for k. After -2, so plus, we always add with summations. After -2, think about your number line. We want to go all the way up to 3. So we start at -2, next is -1. So I'm going to have a -1. Plus, after -1 is 0. That's just going to be -0, but we know 0 doesn't have a sign, so I'm just going to leave it plus 0. Plus, now I have -1, because I'm subbing in a +1 in for k, but there's a negative out in the front. Plus, -2. Plus, -3. And I did a plus and negative, got a lot of signs going on here, so let's fix this up a little bit. Double negatives become a positive. So I've got 8 plus 1/2 times 2 plus 1 plus 0 plus a negative is the same thing as -1 plus -2 is the same thing as -2 plus -3 is -3. So here you can add all these up together. I can see right off the bat here that the 1's cancel, the 2's cancel. I'm left with -3. And now I'm just going to simplify that. So order of operations, I'm going to do my multiplication first. So 8 plus 1/2 times -3 is -3/2. And then you can use your calculator to add them, or we're adding fractions with no equal sign, so we need a common denominator. My common denominator here is going to be 2, so I multiply the top and the bottom by 2. That would give me 16/2, which is the same as 8, so that's good. And now we have the same denominator, so I just subtract the numerator. 16 minus 3 gives me 13/2. It would be my final answer, or 6.5, since it's a short decimal, would also work. And then again, you could do this right in your calculator. So let's pull up your calculator, and we're going to do alpha window. Nope, alpha window, not second window. Number 2. Okay, let's quit there. Try that again. Alpha window number 2, and we're going to say x instead of k is equal to -2. And we're going to stop at 3. And actually, I'm going to restart this. I'm going to type it in right as you see it. So I'm going to do alpha y equals and put in 1/2. So I just wanted to type in exactly what you saw from the beginning as you see it. So here now we'll do alpha window, choice 2, x goes from -2 to 3. And then inside those parentheses, we'll have our -x. And then outside the parentheses, we're going to add our 8 and hit enter, and we get 13/2, same thing that we got before. So just be really careful with those parentheses, whether or not it's in them. So if it's not in the parentheses, just that is. All right, so that's all we're going to do for summations. So just kind of learning what that process looks like. and substituting in from the bottom, stopping at the top, adding them all together, summations. Now we're going to move on to talking about arithmetic sequences in series. So whenever you see arithmetic, think A for addition. The other type we're going to talk about next time is geometric sequences in series, and that's when you're multiplying to get to the next number. Arithmetic is when you're adding. So a sequence is an ordered list of numbers. Arithmetic means you have a common difference, D, between each of the terms. Difference you get by subtracting. So a common difference means what you add to each number to get to the next number. And a series is the sum of the terms of a sequence. So it's taking all of those numbers and adding them together. So a couple of formulas that you're going to have. You're going to have 2 formulas for arithmetic, 2 formulas for geometric. There's only one that's not given to you on your reference sheet that you're allowed to use, and that is the sum for an arithmetic. The other 3 you're given. Okay, so to find any term in an arithmetic sequence, you're going to use this formula, which is given to you, but you need to know how to use it. A sub n stands for your nth term. So it could be the 4th term, it could be the 5th, it depends what you're looking for. A sub 1 is going to be your first term. N is how many terms you have. So if you're looking for the 4th term, then n is 4. And D represents your common difference. Again, the common difference is what you're adding to get to the next term. For the sum of the terms, S sub n stands for the sum of n terms. So if you're looking for the first 3 terms, then that would be the sum of the first 3. N again is the number of terms. A sub 1 still is your first term. A sub n is your nth term, and then you divide the whole thing by 2. And we'll look at that a little bit more as to how to get that formula in a couple questions. So first, pretty straightforward to begin with, we're just going to find the common difference for the arithmetic sequence. So what we're asking for is what we're adding to get to the next term. So a sub 1 here is 5, a sub 2 is 9, a sub 3 is 13, etc. So to do that, just take the 2nd term and subtract the 1st term. So 9 minus 5 gives us 4. So our common difference, or our D, is 4. So that's what you add to each term to get to the next one. And you can do a quick check. Also say, okay, well, what's 5 plus 4? That gives me 9. What's 9 plus 4? Well, that gives me 13, which is the next term. 13 plus 4 gives me 17. So you can do that right in your head, just to double check that you have the right common difference. Okay, now a little bit harder. Let's find the 10th term of this sequence. So they give us the first 4 terms, 3, 5, 7, 9. And hopefully you guys have looked at this a little bit in Algebra 1 as well. But what we want to do is we want to use our formula to find a specific term. So we're going to take our formula a sub n equals a sub 1 plus the quantity n minus 1 times d. So if I want the 10th term, that's going to be our n. So I'm looking for a sub 10, stands for my 10th term. I don't know what that is. That's what I'm looking for. For this formula, I need to know a sub 1. So that's my first term. I need to know n, how many terms I'm talking about, and I need to know my common difference. So my first term is going to be 3, because that's the first one that we start at. N is going to be 10, because we're looking for the 10th term. And D, our common difference, we want to know what we're adding to each number to get to the next. So to do that, take your second term, subtract your first, which gives me 2. So 5 plus 2 is 7, 7 plus 2 is 9. That seems to check. Okay, so we're finding a sub 10. First term is 3, n is 10, common difference 2. And really at this point you can type that right into your calculator, or you can do your order of operations. 10 minus 1 is 9, 9 times 2 is 18, plus 3 gives us 21. So the 10th term would be 21. Now let's say you didn't know how to use the formula. Could you just keep adding 2 until you get to the 10th term? Sure, that would also work. The reason we want the formula, though, is because what if I ask you for the 751st term? You probably don't want to write out 751 terms. So instead, we try to figure out a formula that would work to find that term instead of wasting time of going through every single one. But it would still give you the same answer. All right, and the next one is very similar. Got some negatives in there. I'd like you guys to try and pause the video now and give number 5 a try on your own, and then come back and we'll go over it together. Okay, so again, we're looking for a term. So we're gonna start with our formula. We're gonna write it out. And I'm looking for a sub 25 this time because I don't know the 25th term. My first term here is -7. N is going to be 25 because I'm looking for the 25th term. And D, I'm going to take, and this is where it could get a little tricky, I'm taking my second term, which is -4, minus my first term, which is -7. Don't drop that negative. So that really becomes -4 plus 7, which is 3. So let's double check that makes sense. -7 plus 3 is -4. -4 plus 3 is -1. -1 plus 3 is 2. So that seems to work. Now let's substitute in. So a sub 25 equals -7 plus 25 minus 1 times 3. Again, you can type it in your calculator or just do it using order of operations, and we should get 65 for our 25th term. And that's it. All right, so that's how to find a term. Now let's talk about this formula that I gave you on the first page to find the sum. So this is just trying to get you to understand where that formula comes from in hopes that it might help you to remember the formula and memorize it a little bit easier. Consider the arithmetic sequence defined by a sub 1 is 3. And a sub n equals a sub n minus 1 plus 2. So this is something that we call recursive. We'll look at a little bit later, but this is taking the n minus 1 means the term that comes before a sub n. So we take the number that comes before it and add 2 to it. The series based on the first 8 terms is shown below. Terms have been paired off as shown, seeing this little rainbow here. So what does each of the paired off sums equal? So again, we're counting by 2s. You see that we're adding them together, so that shows it's a series. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So we're adding 2 each time to get to the next. So they're asking what each pair equals. So if I add 3 and 17, what does that give me? Well, that gives me 20. What if I add 5 and 15? 5 plus 15? Well, that's 20. What if I add 7 and 13? Oh my goodness, that's 20. What if I add 9 and 11? Again, that's 20. So each pair, if I add them together, gives me 20. Why does it make sense that this sum is constant? Why does it make sense that these pairs will always add to 20? Well, look at the numbers and try to think about why does that make sense? Well, if we are going up by 2s if we're going forward, you're adding 2 every time. And if you're going backwards, you're subtracting 2 every time. So when you're going forward, you're going to add 2. When you're going backwards, you're subtracting 2 each time. So those are always going to give you that same term or same sum. And in this case, that sum is 20. How many pairs do we have? We have 1, 2, 3, 4 lines of our rainbow, which means there are 4 pairs. Think about how many numbers we had in total. 1, 2, 3, 4, 5, 6, 7, 8 numbers in total. So to get that 4, it's half the total numbers that we have. It says total. Part D, using your answers from A and C, find the value of the sum using a multiplicative process. So instead of just adding up all these numbers, I want you to try to think, how could I figure out the sum using part A and part C? Well, I know that each pair adds to 20, and I have 4 different pairs. So if I have 4 pairs of 20, 4 times 20 gives me 80. Okay, so the sum of all of these terms then must be 80 because I had 4 pairs of pairs that multiplied or added to 20. So now in E, we want to generalize this and create our formula based on its first term being a sub 1, its last term being a sub n, and the number of terms n. So we're going to find the sum of n terms. So what did we do to find the sum of n terms in D here? Well, we took 4, which was half of our total number of terms. So if we have n terms, we took half of them, and we multiplied that by what our sum of each pair was. So we took, like in this green rainbow here, we took the sum of the first term and the sum of the last term, the nth term. We added 3 plus 17 to get 20, and then we multiplied that by half the total number of numbers that we have. And that gives us our sum formula. So try to remember this rainbow here when you're trying to memorize this formula right here. And I think I wrote it a little bit different on the front. I put it all over 2. Whichever way is easier for you to remember is fine. They mean the same thing. Okay, so now let's use it. For number 7, it says find the sum of the first 12 positive even integers. Okay, so what does that mean? The first 12 positive even integers. So the first positive even integer is 2, then 4, then 6, etc. Until we have 12 of them. Again, it's a small number. It would be very easy to write out the 12 and then add them together. And that's acceptable for you to do. But what if I ask you for the sum of the first 1,000 positive even integers? Now that's going to take us a lot longer to do. So we're going to use a formula. So if we're talking about the sum, we're going to use S sub n equals our n. Well, let's use the one that we just did. So n over 2 times a sub 1 plus a sub n. All right, so to find this formula, we're finding the 12 positive integers. So we're looking for the sum of the first 12 numbers. We don't know. Again, this you need to memorize. This is the only formula for this unit here that you have to memorize. So we don't know the sum of the first 12. We need to know n. Well, n, we know we have 12 numbers. A sub 1, the first term, well, we know the first positive even integer is 2. And our last term. So our last term would be the 12th term. So instead of writing a sub n, let's write a sub 12. And I don't know that. And in order to know that, I'd have to write them all out. So this is why this formula is the hardest one to do, because it requires the most work. So you could write out the 12, but what if it was 1,000? We don't want to write that out. So what I'm going to do is over here, I'm going to find the 12th term. To find the 12th term, I need my term formula, which I am given, so you don't have to memorize that one. So I'm looking for the 12th term. My first term, A1, is 2, and here is 12. And my common difference, 4 minus 2, would be 2, because I'm going up by 2 each time. And that gives me 24. So now I know a sub 12 is 24. That's the hardest part, that you have to find that term first. Now I can substitute in. So the sum of the first 12 is 12 over 2. The first term is 2. The last term is 24. So 6 times 26 gives us 156. So if I wrote out the first 12 even integers and I added them all together, I would get 156. Number 8. Find the number of terms in the sequence. So a little bit different this time. We want to find how many terms there are. So we're really looking to find n. Now, my little hint here is avoid the sum formula if you can. So avoid the sum formula unless they ask you to find the total. Unless asked for. So let's use our term formula. So our term formula is a sub n, and lucky for us, we are given this as well, so we don't have to memorize it. And I'm looking for n. All right, so it told me that the first term was 7. So I know a sub 1 is 7. 7, 10, 13, dot, 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 and then the last term is 55. So if I want the sum of all of these terms, I don't know how many there are, but I know the last one is 55. So I know that a sub n is going to be 55 because the nth term there is my last term. I don't know what n is. That's what I'm looking for here. And my common difference, I'm going to take my second term minus my first term, which gives me 3, 10 minus 7. And that looks like it works because 10 plus 3 gives me 13. All right, so I'm looking for my n term. So a sub n, we know, is going to be 55. A sub 1 is 7. We don't know n, and we know d is 3. So now we're just solving for n. We just have a basic equation here. So a couple different ways you could go about solving. You could subtract the 7 first if you wanted, or you might think to distribute the 3 first. Either way would be fine. And then if you did that way, maybe now you want to combine your like terms. So get 4 plus 3n, and then subtract your 4 to get 51 equals 3n, divide by 3, and n gives us 17. And that's good because we should definitely end up with an integer because it's the number of terms. So it must be an integer because it's the number of terms we have. We're not going to have 17 and a half terms. We only have 17. Okay, number 9. Let's see if I can move this down. I'm not always very good at this here. Once I put this in, oh, there we go. I think I did it. Okay, kind of. I brought some stuff with us. That's okay. So number 9 says find the 10th term in the arithmetic series. So to find the 10th term, think about what formula you need and write that out. So I'd like you guys to pause and try to give number 9 and 10 a try on your own, and then come back and check with me. All right, so 10th term, we're talking about our term formula, a sub 1 plus n minus 1 times d. So here we just wrote it out as a series, meaning we're showing that we're adding all the terms together. We're looking for a sub 10, which we don't know what that is. Our first term, or a sub 1, is negative 1. That's the first term. N is going to be 10 because we're looking for the 10th term. And d, our common difference, we take 3, the second term, minus the first term, gives me 4. 3 plus 4 is 7. 7 plus 4 is 11. That seems to work. So now I'm looking for a sub 10 equals negative 1 plus 10 minus 1 times 4. Again, you can type that into your calculator, or you can do it out in your head or check it in the calculator, and that should give you 35. So just a different way of seeing it written as a series right here, but it's still asking for a specific term. And then number 10, a little bit of a word problem here. So a theater has 60 seats in the first row, 68 seats in the second row, and 76 seats in the third row, and it increases in this pattern. We have a total of 20 rows of seats. How many seats are there in the entire theater? So what are they asking for? Are they asking me to find a term? Are they asking me to find how many seats are in a specific row? Or are they asking me to find a total? They're asking us to find a total. How many seats in total? So we're looking for the sum of all the terms. So if we're looking for the sum, we can't avoid that sum formula. So this, just so you get an idea of what we're talking about, this is like saying 60 is your first term, 68 is your second term, 76 is your third term. It's going to continue until your 20th number. So we're going to use our sum formula, and over 2, a sub n, actually we said a sub 1. Try to keep it consistent for you guys. It's a sub n. All right, so to find the sum of the first 20 rows, if that's our total theater, we're looking for S sub 20. We don't know what it is. N, that's going to be 20. That's how many rows we have. Our first term is going to be 60. Our 20th term, we don't know, but we need it. And our common difference is going to be our second term minus our first. So each row, we're increasing by 8 seats. And as we start to introduce geometric, you do want to start to think about, is it arithmetic or geometric if it's not stated to you? So in this case, we weren't told. So you want to say, okay, well, if it is arithmetic, I'd subtract, and I'm going up by 8s. And then say, okay, well, what's 68 plus 8? Well, that gives me 76. So checking it that it is adding and not that you're multiplying to get to the next number, which would be geometric. So we need to find a sub 20. So to do that, we need our term formula. So we are given that on our reference sheet, and we're looking for a sub 20. Our first term stays the same as 60. N is still 20, and D we said would be 8. You can type that right into your calculator. You get 212. So now I'm going to take that, and I have everything I need for my sum now. So N is 20 over 2. My first term is 60, and my last term, or my 20th term, is 212. And again, you can type that into your calculator to add them. I'll let you guys figure that out on your own. Final answer should be 2,720 seats in the entire theater. Okay. And that is it for our 11.01 notes. So we first talked about our summations, and then we also talked about arithmetic sequences and series. I hope that all makes sense to you. Next time we'll be talking about geometric sequences and series, which means you're multiplying to get to the next number instead of adding. And I hope you're all doing well. I miss you guys. And I hope you're having fun doing lots of math dancing. And pie out.